So I drew a little diagram here to show you the problem. So it says the baseball batter hits the ball up to a height of 44 meters. So we know that this is the initial height of the arc. So we know that the degree is going to be the longest it's going to be go is 45 degrees. And we know this because in theory, the higher the angle is, the higher the trajectory. So if it was a little bit higher, it's going to go like this. Higher, it's going to go shorter. And then if we know if it goes lower, it does the same thing. It goes shorter, shorter, and shorter, like that, like I was showing with my mouse. So 45 degrees is the best angle for it to go the farthest. So that's going to be 45 degrees, and we know that he's going to be running at 7.6 meters per second this way. So to find the farthest distance he can be away from the ball, where the ball lands to still get there, we know that the angle is 45 degrees. We know that the maximum height is 44 meters, and that the gravity acting on it is 9.8 meters per second squared. So we had to take this formula right here. The change in y equals the initial velocity times the sine with the angle squared over 2g. So we put in our values that we had up here. So it's 44 meters equals vi sine 45 over 2 in 9.8 meters per second squared, which is all good, but we need to rearrange it to get the initial velocity, because we need the initial velocity so that we can figure out how much time it takes. So we rearrange it, we just plug in the values, and then we square them, and that gives us 41.53 meters per second squared. So that's initial velocity. So then we're going to take the time of that, and we know that it's 2 vi sine over grams. I mean, not grams, I'm sorry, gravity. So we take 2 times what we found here, the initial velocity, times the sine 45, the angle that it was hit at, and then 9.8 meters per second squared, which gives us 6 seconds. So we know we need to find the distance that he can travel, which is 7.6 meters per second, because that's how fast he can run, and we know the 6 seconds is how long he has to get there before the ball hits the ground from here. So because it's going to be 6 seconds before it goes from 44 meters down, so we know he has to run 6 seconds. He has 6 seconds to run, because it's going to take 6 seconds to get here. So let's say he sees it there and he has to run 6 seconds. So 45.6 meters away is the farthest he can be before he can, in 6 seconds. 45.6 meters is the farthest he can run in 6 seconds. So that's how far away from the ball he can be. If he's closer, he can get there faster and he'll have plenty of time, but the farthest he can be is 45.6 meters. So the values we found were that it's going to travel from 41.53 meters per second, because, I mean, we don't know what the height is, anything from here, so we had to find it from 44 meters, and that's why we put 44 meters in here. So we wanted to find the initial velocity from at this point to down. So, yep, and that's it. And our answer for the question, the farthest it could be, would be 45.6 meters.